jumping through like jeez. Bum 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 bum. Hello, my beautiful people that are in grade 12. I hope you're good. We are here, we are here, we are here, we are here to shame the devil, to make ourselves proud, to make our maths futures a bit brighter. We are here to make an appointment with destiny, right? Yeah. We are here to run our best race that we've ever run, ever in 2025. So to do that, we'll be jumping and diving into today geometric sequence. Geometric. Yesterday, we wrapped up the section on arithmetic sequence. Okay. I'm going to school tomorrow with a very fresh mind. Oh, you guys, oh my, some of you are going back, ne? Oh, grade 12, I know for sure. Yeah, guys, you guys are the one. Respect to you. Ghana M1 or Kanene, which school is that? That you, or maybe it's fine. Don't comment. It's fine. You don't have to comment. Actually, you can just send me an inbox sometime. Don't worry. Don't comment. It's fine. Just keep it. Yeah, because sometimes it's public platforms like this. Yeah, just leave it like that. You can just contact me on the side and let me know. But that's phenomenal. I'm glad some of you are having a chance to go back to school a bit early. This is grade 12, Remo, REMO. Yeah, REMO, Remo. All right. So guys, we're looking at geometric sequence today. We've done quadratic sequence. We did arithmetic sequence. Now we are doing geometric sequence. So let's dive right into it and waste no time. So a geometric sequence, good people, as I'm sure most of you already know, because some of you have been doing individual personal work, which I'm proud of. You guys are great. Like, I commend you. I really commend you guys that are doing above and beyond. You are just putting in the effort. I'm always happy. I unfortunately have not told my grade 12s to come back anytime early. I've said to them, I'll see you guys when schools reopen. I already gave you my instruction for what you guys need to be busy with during the holiday, so that by the time me and you meet officially when we reopen schools, you'll be where I want you to be, and then we can just push from there. So I commend you guys who are going back to school tomorrow, and yeah, just take everything with a positive attitude. Please also show the utmost degree of humility. Be humble. Don't be arrogant. I know some of you will want to, compete, outshine or outsmart the teacher or something like that, because you feel like you've been taught or you've been pushing on your own. Just try and be humble. Very importantly, I'm sure you guys know your particular teacher that you'll be going back to, but please be humble. I plead with you. Do not be arrogant. Grade 12 is not the year to be arrogant or try to show off. What you need to do is to work very hard in your private corner. Your personal private work that you do is of utmost importance, because if you dedicate yourself fully, privately and personally, you are going to see it's going to come out publicly. People will be able to recognize you. You have a color. Alright, let's go. So geometric sequence is a sequence where, what is this sequence? It is where a ratio, hey, this word ratio. Guys, you remember in grade 8 and 9, you guys did ratio. And when you defined ratio, you defined ratio as the comparison between two quantities of the same type. And the way you represented a ratio is you wrote it as this thing. It would be like 5:8. But a ratio of 5:8 can be written as a fraction, because remember, this is a rational, hey, connection, rational number, okay, rational. So 5:8 can be written as 5/8, because a ratio has direct connection to fraction. Because remember, what is a rational number? It's a number that can be expressed as a fraction, where the numerator and the denominator are integers. So I hope we are together here. So a geometric sequence is a sequence where the ratio between the what? The consecutive terms. What does this word consecutive mean? I'm sure by now you've gotten what the word consecutive means. The ratio between the consecutive terms remains what? Constant. So in other words, term 2 divided by term 1, the later term divided by the previous term, is equal to the later term divided by the previous term. T3 divided by T2 is equal to the later term divided by the previous term. And I mean, we could go on forever depending on how many terms we have. T2 divided by T1 will be equal to T3 divided by T2 will be equal to T4 divided by T3. That is our R value, which is the symbol or the letter that we use to denote what a constant ratio is, R. Okay. So in a geometric sequence, right, the letter A, small letter a, like in an arithmetic sequence, will stand for the first term, okay, which is basically T1. So we can use A as the letter to denote the first term. R is the letter that we use to refer to the constant ratio. Constant ratio. So this time around, we're not talking about a constant difference. We are talking about a constant ratio. Because for consecutive terms in a geometric sequence, then the ratio is constant for consecutive terms, right? Then we use this formulation T2 divided by T1 to calculate the constant ratio. We can always confirm by T3 divided by T2, T4 divided by T3, T5 divided by T4. I hope you get the flow. So let us consider a sequence here. And let's look at this sequence. 3, 6, 12, 24, 28. Please note what's happening here. 3 to 6, 6 to 12. To just check, we can see that there's no difference that's constant here, because 6 minus 3 is 3, whereas 12 minus 6 is 6. So there is no difference here that is constant, but rather from 3 to 6. Good day, people. Is it me with a bad network problem today, or is it sir? Yes, please answer that question that Wilmore is asking. My network says good connection, so I believe my connection is beautiful. In fact, it's handsome, it's gorgeous. Okay, so Eldorado has confirmed it's you, Wilmore, and King MC is also saying it's Wilmore. Thank you very much, guys, because I can see my network is gorgeous today. It's gorgeous, guys. Consider the sequence 3, 6, 12, 24, and 28. So here we can clearly see that there is a From 3 to 6, we times by 2. From 6 to 12, we times by 2. From 12 to 24, we times by 2. So in other words, 6 divided by 3 gives us 2. 12 divided by 6 gives us 2. 24 divided by 12 gives us 2. And 28 divided by... So basically here we can see that the constant ratio is what? Is 2. Let us continue, guys. We see here that the constant rate, the first term is 3. Let's start there. The first term is 3. Yes, it is 3. A is equal to 3. But R is equal to what's 6 divided by 3? It's 2. What's 12 divided by 6? It's 2. So our constant ratio is 2. Let's continue. Let's look. Let's just explore this. So term 1 is equal to 3, which is equal to A, right? No problem. For term 2, which we could see is 6, right? Term 2, which is 6, we get it by saying 3 times 2, which in other words means A, which is the first term, times R, which is this 2, right? Let's move on. What about term 3? Term 3 is 12, which is equal to 3 still, which is the first term, but multiplied this time round by 2 squared. 2 squared is 4. What's 3 times 4? It's 12. But this 2 squared, okay, the 2 is there, but it has the exponent 2. The 2 base here is there, but it has the exponent 1. I hope you guys are seeing what's happening here. So this is A times R, but R squared. That is term 3. What about term 4, which is 24? Here we have 3 still, the first term, times the constant ratio, but it's raised to the power what this time round? 3, because 2 to the power 3 is 8, and 8 times 3 gives us 24. So generally speaking, we can say this is A times R to the power 3. Are you feeling me? I hope you do. So generally we can say Tn, if we look at the general nth term, the general nth term, Tn is equal to 3, because it is the case, times 2, that is true, to the power n minus 1. So for this pattern, 3, 6, 12, 24, we could use the general term 3 times 2 to the power n minus 1. And for any general term of any geometric sequence, we could say Tn is A times R to the power n minus 1. And it's always minus 1. Please check here. T2, R to the power 1. T3, R to the power 2. It's always 1 less than the 3. Look at there. The square, it's squared. 1 less than the 4, 3. 1 less than the n, A, R to the power n minus 1. So this is the accepted formula for the general term of a geometric sequence. It is what? Tn is equal to A times R to the power n minus 1. This is the accepted general term for any geometric sequence. Okay, I hope we are feeling it. Where A is the first term, R is the constant ratio, and n simply is the position of a particular term in the sequence. Okay. Can I continue from there? Do we grasp the concept of what a geometric sequence is and its general term? All right, because guys, it's important to grasp this part, because our development of the concept helps us to then move on to calculations. The calculations are a natural flow from the concept. When the concept is grasped, then we can go on to calculations. Now, here is the thing now. Since we know what the formula is, the formula Tn is equal to a r to the power n minus 1, the formula can be used to what? To determine or determine the value of any specific term of the geometric sequence. So if we want to determine any specific term in the geometric sequence, we can use the formula. Tn is equal to a r to the power n minus 1. The formula can also, secondly, be used to determine the position. What do we mean by position? It means the value of n of any term in a sequence. If I'm given a specific value and I want to find out what its position, I can use the general term as well. By what? By doing what? By equating Tn to the given value of the term. All right? And then do what? Then solving for n. This is where my solving for quadratic equations comes into play. Okay? This is where all of this comes into play. So for grade 12, this comes into play. All right? Then, very importantly, to solve for an unknown in an exponential equation, we can use some of the following techniques. Now, I'm sure, guys, we know what exponential equations basically tell us. Whenever we have an exponential equation, we know that we need to ensure that the bases on